Right, so here we go. So my name is Chris. I am a iOS developer with the Dyson team, and I'm here today to have a little chat with you about SwiftUI, which is a new framework for creating interactive user interfaces that Apple's sprung on us at DubDub this year. So what I'm going to do, first of all, we're going to look at where we are now with storyboards, interface builder, that sort of thing, and see exactly what the problem is that SwiftUI is hopefully going to fix. We're going to have a look at what SwiftUI is and how it's going to fix the problems. We're going to look at some of the technologies behind SwiftUI. There's a few other things that were announced at DubDub that are quite interesting that have sort of powered SwiftUI and got things moving. So we'll have a look at that. I'm going to run through a quick example just to show you what the code looks like. And we're going to talk about how easy or difficult it is to migrate from UIKit to SwiftUI. So here's where at the moment with storyboards. Some people like them, some people don't like them. I think there's quite a few problems with them. List a few now. Cannot be edited by hand. They're sort of glorified XML files. I don't know if anyone's ever tried to actually manually edit a storyboard file or a zip file or anything like that, but it's just not really the thing you can do. And related to that, you get a lot of merge conflicts. Two people who worked on the same storyboard, same zip file, things like that. Then when you actually come to merge, quite often you'll get a conflict and fixing it is nearly impossible. You just need to delete it all and start again. You also get a lot of arguments. I don't know if it's the same way you work and the other iOS developers. We get a lot of arguments between programmatic versus interface builder, so whether people prefer writing the code to create the interface or whether they like to use interface builder or a crossover of the two. Either way, there's always sort of, we have a lot of discussions about that and no one really has a good answer. We end up with a code that's spread across many files. So you've got some stuff in the interface builder, some stuff in in the zip files, in the storyboards, in the Swift code, things like that. And if the storyboard goes, then it's potentially a whole app could just totally die and start all over again. So I don't think interface builder. I think storyboards are particularly safe with the IB outlets, which are a bit of a hack, if you ask me. If you happen to delete a property that's linked up in an IB outlet, or you delete a function or something like that, you won't be told about it at compile time. You'll get a runtime error, your app will die, and the error messages aren't very clear either. Stringly type identifiers, there's so many problems. So we've got reuse identifiers for your for the view controllers. Your cell dequeuing identifiers, they're all strings. I mean, you can rework them as enums in your code, but at the end of the day, in the storyboard, it has to be a string, and there's so much potential for failure there. And again, it's not checked at compile time, so you end up with mystic runtime errors. And typecasting, a lot of it depends on typecasting. When you dequeue a cell in a table view, you need to typecast out with a forced cast, and there's no guarantee actually that that's going to be the right type, and you can end up with another crash there. So what's SwiftUI doing to address that? SwiftUI is intended to be the best of programmatic and interactive visual design. So everything is written and everything is composed programmatically, but you also get the advantage of a preview pane which shows you exactly what you designed. That's live. It's got some really nice features actually, which we'll get onto later. So you do get that visual design on top of the advantage of programmatic. You don't get it split across files, so stuff like source control is all done for you. It's all handled nicely. It's a declarative language. We're used to writing UIKit in imperative style, where basically you say when you load your view, you say you want a table view. It'll make the table view, as you know, then it'll call all these delegate methods and it'll call your data source when it needs it to access everything. So you end up with a long list of functions all in different places again. Whereas with declarative, what we're doing, you'll see it when you do the demo, we are creating a list of rules which the UI is going to follow. Basically, we create a framework in one place, and then that's all we need to do. It basically looks after everything for you. It's safe. So unlike what we were just talking about with interface builder, everything is checked at compile time. There's no sort of relationships between the interface and the code that can break or anything like that. It's very fast as well. So although a lot of it is built on top of UIKit, it's not strictly a wrapper for UIKit. There's a lot of SwiftUI has been built from the ground up, and a lot of it is actually bypassing the core animation layer that UIKit is built on, and it's actually running directly powered by Metal, which makes it really slick and fast, hopefully. It's multi-platform, so the same code or the same API can be used across iOS, macOS, iPadOS, watchOS, tvOS, everything like that. So if you learn if you learn SwiftUI on iOS, you'll be able to build a UI on macOS and all the other app platforms. And it also provides implicit support for dark mode and dynamic types, so they just work if you use this. So all the latest sort of Apple technologies are all implicitly supported by SwiftUI. Okay, so let's have a look at the sort of technologies that are powering this. There's been quite a lot of advancements in Swift 5.1 that now makes sense when you look at it in the context of SwiftUI. So implicit returns, so closures with a single expression. You don't need to use the return keyword, it'll just return that expression. Opaque return types as well, so functions can now return protocols with dependencies on self or associated types using the sum keyword. And both of these come together to provide something called a function builder, which we'll see a little bit later when we look at the code. It's basically a custom attribute type that can, it creates a function that returns transform its statements into a collection. We'll see that a little bit later. Combine, which is Apple's reactive framework. Sorry, I switched to that. Yeah, combine. Property wrappers, by the way, that's just things like. Well, property wrappers, that's that's how they handle state. We'll look at that in a little bit as well. Yeah, so combine the reactive framework. Metal, as you said before, a lot of it's powered by Metal, the graphics engine. Catalyst as well, which is a big step towards unifying the platform. So, like I said, if you're familiar with building iOS apps, you'll be able to make macOS apps too, in theory. Okay, so let's have a look at what we're going to do. So in this code demo, we're going to come up with a simple music library, something like that, hopefully using as little code as possible. I'd love to have done a live demo here, but this isn't running Catalina, and then you won't get the preview window, so it's not sexy. Right, so you start a SwiftUI project, and this is what you'll see. This is just a simple hello world, so we can see the content view, that struct, that is the initial view presented by the app. As you notice, it's a struct, not a class, so it's actually all passed by value type, which is a big change actually with SwiftUI over UIKit. That conforms to view, and view is now, it's actually a protocol now, and the protocol requires a body variable, as you can see below. So that body variable just returns everything you need to draw that view, basically. And you'll notice that the type of that body variable is SumView, which is an example of the opaque return type we were talking about before. So we can actually specify a return type using a protocol, which has a dependence on self, which is what we're seeing there. And that wasn't possible for Swift 5.1. So what we're basically doing, we're telling the compiler that function will return some sort of view, but we don't need to know exactly which view it will return at the moment. That'll all make sense a little bit later, hopefully. So if you want to improve this, make that text look a little bit better, we use modifiers. So what we've done there, we've taken that text label, we've added a font modifier to change the font, and we've added a colour modifier to change the colour. So each of those modifiers basically acts on the one on the previous one, so you can change them all together. So that's how we do text. If you want an image, quite similar. We use an image element. So we create the UI image, and then in the body we're returning the image using the UI image. If that makes sense. That can also, we can use a system image there, which we'll see a little bit later. So at the moment we've just dropped the image and to the view, and it's in the original size right in the middle. So if we want to change that, we can add more modifiers. So make it resizable. We set the aspect ratio, we set a frame for it, and we've even added a little clipping frame around the outside to give it a rounded rectangle. So you can also very easily make sort of circular images and things like that just by using these modifiers. So they're quite powerful, very powerful. So that's quite a basic one. If you want to actually compose a view from multiple views, it's a little bit tricky because this body variable, that can only return one single view, exactly one view. So what we need to do is use a container. So here we are using a vStack container. This will be familiar to anyone who's used UI stacks. Well, similar in the way it lays out, not similar in the way it works. So this vStack is initialized with a closure, and what we're seeing here, this is what we were talking about. This is the view builder type of closure. So basically, it's a bit of a weird syntax. We've got no commas. It looks like an array, but it's not an array because there's just a list of UI elements with no commas or anything like that separating them. Because this is a view builder type, it will take that and it will push that into the vertical stack. So we end up with something like this. And then all we're returning is just a vStack from that function. So we can use these to build the internal view hierarchy. And we can format it by adding parameters to the vStack initializer. If we want to get a bit more compositional, here we can embed a horizontal stack within the vertical stack. Again, we've got text, got a bit of formatting on the text there and the image. Here we're using the new system images, which I think you'll hear about in a little while. The spacer just separates the two sides. Quite an interesting thing here, we've got the background colours being added after the padding, which actually gives it this effect. If you put the background before the padding, it'll just put the actual colour just behind the text, and then it'll still add the padding. There's a few little weird workarounds you can do with this sort of chaining. Obviously this could get complicated with large UIs, putting it all into the content view, so ideally you want to move all this into a custom view. And that might look something like this. So what I've done here, I've created an album view, which actually takes an album as a parameter, and you initialize it, and that will provide all the data. Quite an interesting part of this as well. This album view previews struct. This is what this preview pane here actually uses to draw its contents. So this also returns the previews, which is a view. And what we're doing, we're actually we're creating an album view with some sort of sample data in it, which is what we're seeing here with the album title, artist, and then that's what's being used to create the preview. That makes sense?
Can you give a bunch of those?
Where, sorry?
Can you give a bunch of those previews?
In here?
You want to test like 20 or 30 cases?
No, I don't think you can there. You can?
Yeah.
Oh,
Yeah,
cool.
we can.
Yeah?
Yeah.
Okay, yes you can.
Nice.
Well, do you actually just return it in like a stack or something, or return it as a view?
But you could set like environment options on each one, so you could have like an iPad preview and an iPhone preview.
Yes, that sounds good. Yeah, that sounds clever.
Different test pages as well, I think.
Yes. So we get now we can see the two album views in our original content view side by side. So if we want to make these interactive, how do we do that? This is where the state attribute comes into play. So I've set up a new property playing with the state attribute, which is defaulting to false. What that state attribute does, it means whenever that property changes, it will refresh the contents of the view. And then I'm basically adding and hiding a new icon over the top of the album title based on whether playing is true. Using the Z stack there, which actually piles things on top of each other, which is quite nice. There we go. So we've embedded that play label inside a button with an action that will toggle the play state. So when that changes, then what we'll see there, that's when it's true, and that's when it's false. That's all handled automatically. The preview pane is cool actually. Yeah, you can, like you say, you can preview the device on several different devices at a time. You can switch between different dynamic font sizes. You can switch between dark mode and light mode as well. If it was running live, I could show you. Actually, didn't mention actually, but this button here, once you tap that, this whole preview pane actually turns into a live simulator view, so you can actually test on the fly in the preview pane. And obviously any changes we made in that custom view will be reflected back in our content view. Lists have also had a major overhaul with SwiftUI. It's now very, very quick. I mean, before we had to extend our list view, you had to make callbacks to a data source and things like that, and you had to tell it how many rows you wanted, how many sections you wanted, and things like that. How many rows you wanted in each section, stuff like that. Don't have to do that anymore. This is a very simple demonstration of a static list. We just chucked in a load of rows. Don't even need to be what they're called, table row cells or whatever, table view cells. We can just chuck in one of our standard views. And dynamic lists as well. You can basically make a dynamic list from any content type very easily, as long as your element conforms to identifiable and provide an ID. That's all you have to do. So you're feeding the list element with the content, and using the closure to actually generate the rows of the table. There's lots of other things which I probably won't have time to cover now, and I haven't really looked into them yet. So binding, that's where you get a sort of a two-way dynamic communication between the interface and the models. That's all sort of taken care of. There's some quite advanced methods of doing that as well. You don't just have to bind to basic variables. You can bind to an entire data model and things like that using the object binding attribute. There's an environment object attribute which is used to share data between views. Transformations and animations are all covered by SwiftUI. It does it very nicely actually. It's very easy to set up really comprehensive animations. Forms, which is a really slick way, you've probably seen it in the Apple system sort of dialogues of capturing user interface, capturing user data with a really nice interface, and all the controls you use actually adapt when they're added to the form. They actually adapt their style to match the form. Navigation. For each is a really cool little feature. Basically, any collection you can create views from programmatically, and obviously tons more interaction which I haven't covered yet. Control events, gesture recognizers, view life cycles, they're all covered. So in terms of migrating UI kits to Swift, there's obviously one-to-one mapping with quite a few elements. I mean, they're not used exactly the same way, but they'll basically do the job for you. So as I said before, much of SwiftUI is built on top of UI kits, not all of it, but there's plenty of, if you know UI kit, then a lot of the sort of elements are the same. A lot of the properties have become SwiftUI modifiers, that sort of thing. Things like auto layout's not exposed to Swift, so you need to sort of use a sort of like web box style paradigm to do your layout. I think with SwiftUI you can, right now out of the box, you can get it sort of 90% of the way there. The tweaking, sort of the last 10% is a little bit more tricky to do, but I'm sure it will come as we learn new techniques. Obviously data flow is completely changed with Swift. You still use sort of MVC models, but you'll need to probably rework quite a few things in your out there. You need to target the latest OS version, so as we'll see in the next slide, iOS 13 is required, which is probably going to roll out for a lot of people using it for the next sort of year or two, sadly. Don't forget that. There are still a few things missing from SwiftUI. There's no collection view yet. Attributed strings aren't supported, although you can concatenate texts. Probably find more things as people delve into it a little bit deeper. Probably find more things that are missing, and hopefully they'll be added. And there's still some strange error messages. I think anyone who's used like RX Swift or anything like that probably seen this, where you've changed a load of expressions, and somewhere along the line the compilers fail to infer a type. Then you get an error message that's really hard to understand, somewhere completely unrelated in the code, or 3 lines up or 6 lines down or something like that. So that happens quite a lot, I find, in the couple of hours I spend with it. So yeah, this is what we need. iOS 13, so it's all the latest operating systems, but it's the only one to support SwiftUI. probably thanks to ABI stability. So that's it. And,
Has anyone got any questions before we switch over?
I have a quick one. So when you're generating the file, when you're using the UI, you need to create, how much does it basically mess up the code when you use the UI generator?
oh, it's pretty good actually. Well, when you change the properties in the preview pane,
Yes,
you can
exactly.
adjust
When
the
you're using like the GUI for
I found it quite slick actually. I mean, it depends on mess up. I mean, you can obviously write your code in whatever style you want, but that it won't know what style you want it. It'll just use sort of a system style. But that's a good one to stick to, and it actually works quite well.
Okay.
Yeah, I think it comes out.
I did just a quick question. Why is it known why what is the latest version of iOS?
What is, right?
Yeah, so SwiftUI you're saying it only works on iOS 13.
Yes.
Is that why is that? Do you know? Is it a technical limitation, or is it more about getting it like? If it was supported all the way back to iOS 9, then people would start using it straight away now, wouldn't they?
Yeah.
Whereas, do you think that's like an artificial limit, or is it a technical limit?
I imagine it's a technical
API
limit.
stability.
Yeah, because you can't bundle the runtime anymore with the app like they used to be able to do.
Okay.
So it actually needs to be supported by iOS.
Okay.
It's the range. That's where all the load is coming from.
Okay.
There
So-
could be some things like combine as well, because it's data flow stuff, so how data is pulled in into this view, so it could be plenty of things, and I think we have a big step forward with all of these things, but it's not like but Apple doesn't care about it.
No.
So, in 2 years, I think it'll be there.
Mhm.
Well, thanks, Chris. Cheers.